Hello everyone. Good evening to all of you. We are just doing some technical thing. Shortly we will start our webinar. Please stay with us. I will request to all the participants who are in our Google Meet group, please switch off your mic and your video and your camera. Please setting the YouTube live streaming. That's why we are taking some more time than the schedule one. Please bear with us. We will shortly start our webinar. Hello everyone, welcome to the Young Biologist webinar. So this is our second webinar. After 3 days live, today we are here enzyme kinetics and basics of molecular docking. So before starting, I beg sorry to everyone for the glitches. Actually, our list of participants are way more than we have expected. So it's initially we have set this as a Google Meet platform meet only, but the participant list is way more than 1,000, and there are hundreds of participants from the foreign nationals also. So collecting their all WhatsApp number, everything, and putting in one thing, so it's different. We don't have their everyone's ISD number. That's why. So don't want to go to that technical part. Uh, we thank everyone for bearing with us. So now I will call Younger Biologist founder Kanak Chakraborty to tell something. So Kanak Chakraborty, Kanak sir, please introduce yourself.
Sorry for the technical glitch. This is our second webinar. Before starting, I just want to introduce young biologist. What is young biologist and who are we? Actually, young biologist is a platform for the young generation and to popularize the biological science among young generation. We are the group of young faculties, research scholars, and biological experts from industries. And what is our aim? Most probably, you want to know what is our aim. Our aim is to popularize the biological science amongst the youth. Our objective is very clear. It is to deliver basic knowledge on different field of biological science by just conducting webinars and short-term courses. And these webinars are completely free of cost. We are emphasizing on delivering knowledge in an innovative and interactive manner. This is all about young biologist, and I have many more things to say, but it is already late now. So I want to just hand over the mic to Mr. Omid. And Omid, you just introduce the our speaker to the audience, and let's start.
Thank you, Kanak sir. Let me tell to all the participants, after the webinar, you will given the feedback form in your registered mail ID. You can fill this. You have 24 hours from the end of this webinar to fill the form, and we will deliver the certificate within next 7 days. So there is a short bio about Dr. Aurobindo Ghosh, today's speaker. He has born in the historic Ahom capital of Assam, Jorhat, in the year of 1982, and completed his preliminary education here. Gold medal under the Dibrugarh University. Soon after, he joined Dibrugarh University to study PG in bioinformatics and successfully completed in the year 2007, securing the first class second position. In the same year, he has joined Northeastern Hill University for higher education and completed his MSc in biotechnology and bioinformatics. In the year 2009, with the first class first rank. With strong motivation of building a good academic career, Dr. Ghosh has joined the prestigious Indian Institute of Technology, Guwahati, in 2009. Meanwhile, he had selected to pursue his research career and to carry out his PhD work in Tokyo University, Japan, and IIT Kharagpur. A major breakthrough in his career arrived in 2015, where he has awarded the Doctorate of Philosophy from the Department of Bioscience and Bioengineering in IIT Guwahati. After making a concrete platform of research, Dr. Ghosh has joined the oldest university of Northeastern region, that is Guwahati University, as an assistant professor in the Department of Botany, where he is continuing his career as in teaching and research. Dr. Ghosh has attributed career in research in the field of biotechnology and credited with 23 publications with good impact in the scientific community. Two books, six book chapters, 30 conference presentation. He is the life member of many professional scientific societies such as BRSI India, AMI India, the Society of Biological Chemistry India, member of Indian Science Congress Association. He is also involved as poster reviewer and editorial board member of many reputed journals, such as Indian Journal of Phytopathology, Spring in Nature, African Journal of Microbiology Research, International Journal of Genetics and Genomics, etc. Before being recognized by INSC Award, he is recipient of INSC Research Excellence Award 2019, BISR Young Scientist Award 2019, EK International Young Research Award 2019. So I will request Dr. Ghosh to proceed with today's topic. Dr. Ghosh, please.
Yeah, very good morning to everyone. Am I audible?
Yeah, Dr. Ghosh, you are audible.
Yeah, thank you very much, Kanak and Amit, for giving my introduction. And I'm very much thankful that you have invited me on this platform to share a little bit about the basic principles of enzymes and docking, those on which I'm working at present. But I would like to say here that here I have gisted most of the things that is very basic about theoretical knowledges and few practical perspectives. So today uh, I'll give a little information about the type of the enzyme. Mostly the people have already studied this part of enzymes from class 11 onward. But the thing is that due to the lack of brush up, we are usually forget everything. So let's brush up something and why it is required, why to know about the enzymology, and at this present scenario, the importance of the enzymology I'll mention here. So before going to that, I'd like to share my slide. Uh, Admin, please allow me to share my slide. I'm unable to share my slides.
Yeah, Dr. Ghosh, you just try again.
Yeah. You must grant permission, they are asking. It's asking about I have to grant permission.
You have already given the permission.
I don't
You
know.
already given.
Yeah, I'm just wait. Let me check again. Might be due to some technical glitch again. These things are happening, but still this, they are asking me same thing. Yeah, admin, a young biologist. Are you listening?
Yeah, Dr. Ghosh, can you just clear the meeting and
Yes,
rejoin again?
yes, that I'm going to this. Actually, I'm looking for the permission. Yeah. No, still it is asking. I need permission.
Dr. Ghosh, here we don't see anything.
I don't know.
You try to present your slides. Is it possible? Present now in your screen.
Yeah, yeah, I know that. Yeah, I'm doing that. But when I while I'm trying to share my entire screen on the window, it is showing a message that you need to take permission.
I think someone is presenting then. Let me find it.
Yeah, please.
No, I have just tried to presenting if that happening with everyone not, because I am not handling with an admin profile, but still I can present. So Dr. Ghosh, technically you should also present. You can present. Try once again.
Same thing is asking. I don't know why. Same thing is happening. Same thing is happening. I don't know what is happening.
Dr. Ghosh, can you present
Yes.
now?
No, still I am unable. Still it is saying that you need permission. Why so? I don't know.
But
Even
no
I
such
have,
dialog box popping up here.
yeah, even I have presented earlier from this laptop also, but I don't know this time why is it showing like this. What is the just a second?
Sir, do one thing
Yeah.
after you def and join by clicking the present button.
Which one? Oh, you are giving. Yeah, I can do something. Are you listening?
Since Suryanarath is present, uh, I can present.
Are you listening?
Yeah, yeah. Pinku, stop presenting. Sir, everyone here able to present now.
Yeah, just I'm doing one thing. Actually, my friend is also here in this group, so I'm sending him. He will be presenting on my behalf. Just the slides. I'll be telling the stories. Okay.
Okay, sir. Okay, sir.
Okay,
Yeah,
that's good.
that will be the best option, I guess, at this moment. Just a moment. I'm sending him. Yeah, hello. হ্যাঁ কি করবো ইএম ব্যালেন্স ইএমআই কি করবো হুম হুম ये वाला लैपटॉप का प्रॉब्लम। हेलो यंग बायोलॉजी।
Hello. Yes, sir.
आज सचमुच में मेरा लग गया एक नया टॉपिक ढूंढने में।
Am I visible now?
Yes, sir.
Am I visible now?
Yeah, you are visible, sir.
No, no, my slides are visible or what?
Yeah, your slides are visible, quite visible.
Slides are visible, right?
Yeah.
Okay, thank you, sir. I'm so sorry about.
No, sir, it's okay. Sometimes it happens with us or even.
Um, my slides are visible. Oh, yeah, visible, right? Okay.
Yeah, it's visible, sir.
Okay, fine. Sorry for this technical glitch. So today I'm going to present here about the enzyme kinetics and the basics of molecular talking. Already 40 minutes I have spent with this technical glitch. So I'll go a little faster. Please don't mind about that. So as we already know, what are the enzymes? Enzymes are usually the biological catalysts. They carry out the reaction. They usually speeding up the biochemical reactions. Most of the enzymes are three-dimensional globular proteins and tertiary and quaternary in structure. Some spatial RNA species are also known as this RNase enzyme, and this is not the last. More examples are like enzymes, DNA enzymes, and nanozymes are also available. So interestingly, nowadays the nanozyme has taken more pronounced because nanoparticles are getting the properties of the enzyme, and they can catalyze many chemical reactions, and it is very industrially very much important. And my present work is really totally focused on this nanozyme. Still, I'm working on it. So I would like to give a brief classification of the enzymes. Usually the enzymes are classified in six distinct classes. Class 1, oxidoreductase. So usually it will carry out the oxidation and reduction reaction, and the important subclasses within these oxidoreductases are there's dehydroxygenases, oxidases, peroxidases, reductases, monooxygenases, dioxygenases. So followed by that, transferase. Usually this enzyme transfer the groups from the substrate to the product and from new product. And the important subclasses are the glycosyl transferases, the C1 transferases, aminotransferases, phosphotransferases. Then hydrolases is a very important group of enzymes. So usually this kind of enzyme involved in the breakdown of the bond of substrate, which has been associated, like for example, in case of carbohydratases, it breaks the glycosidic linkage, and based on that, the subclasses has been classified as esterases, glycosidases, peptidases, and amidases. The fourth class is lyases, or anotherly known as syntheses. So the subclasses are carbon-carbon lyase, carbon-oxygen lyase, carbon-nitrogen lyase, and carbon-sulfide lyases. Fifth class, isomerases, usually involved in the isomerization reaction. The important subclasses are epimerases, cis-trans isomerases, intramolecular transferases. And the last class is very important in case of molecular biological perspective. That's the ligases, or anotherly known as synthetases. Usually the subclasses are involved, incorporated in this class are carbon-carbon ligases, carbon-oxygen ligases, carbon-nitrogen ligases. The enzyme, there are two basic enzyme models or the principles on to which the enzyme, the enzymatic chemical reactions are taking place. There's a very primitive type of model is lock and key model, where both the substrate and the enzyme, they are rigid bodies, and there is a fixed surface onto the enzyme, or the fixed active site onto the enzyme, where the substrate will go and bind. You can see the shapes are already predefined, and accordingly the substance goes and bind onto the site. Finally, products form. This product is formed, and the enzymes which has been taking part in has been come out. Then the another type of is induced fit model, where both the enzyme active site can accommodate the substrate based on its shape. That means it can modulate its shape or the active site where the enzyme, the structure of the enzyme can fit into. The structure of the enzyme fit into. So that means the enzyme can change its active site to fit, or the shape of the active site to fit the substrate for the further chemical reactions. Now it's a very basic concept.
Interesting. Sir, can you just hide the presenter screen? Like stop sharing. There is a button hide. You can click there and hide that bar.
Okay, okay, okay.
And now you can make full screen, sir.
Yeah,
Yeah,
thank you.
yeah.
Thank you.
It's and sir, if it is possible, just try to pronounce the word little bit slow as it's producing much echo.
Okay.
Yes, sir. You can quite carry on.
Is it okay now? Okay.
Yes.
Usually the enzymes lowers the activation energy that we have read in many books, and what is the basic basic mechanism behind that. Whenever a chemical reaction is taking place between two reactants to form a product, there is a phase or intermittent phase is called as the transition state. The transition state is the high energy barrier which prevents the reactants to form a product. It is not so easy to overcome, and the minimum energy required to overcome that transition state is known as activation energy. Now, what is the role of the enzyme? Usually, enzyme lowers the activation energy. Enzymes, you can see here, this is the transition phase of the chemical reaction, and here this is this blue line. This signifies the enzyme that lowers the activation energy, and due to which it can carry forward the reaction faster than the any other chemical reaction. That's why it is anotherly known as biocatalysts. So here is a pictorial diagram. You can see a man is pushing a iron ball over a over a dome surface, and it is very difficult to cross this dome barrier. That barrier is known as transition state. Now, when if that person can remove that dome with the help of a spade or something, that means what? It is reducing the dome surface, and easily he can push that ball on the other part. That means what? Similarly, the enzyme acts as a spade here in the chemical reaction. It removes the transition barrier, and simply the chemical reaction moves forward and finally attain the equilibrium. So here is the formula how this activation energy have to calculate. This is a kinetic property, or this is the kinetics here. So now basically we come to the enzyme kinetics. What does that mean? What is enzyme kinetics? The enzyme kinetics is nothing but to know about the properties, how these enzymes are working on the dynamic environment, how these enzymes are reacting, this facilitating the conversion of the substrate into the product. In the absence of enzyme, the rate of reaction can be thought to increase linearly with substrate concentration. Now the first term here comes the rate of reaction. It is a very confusing initially. We know about what is the rate of reaction in chemical reactions, but it is simply, if I define here, this is simply the conversion of the substrate into product with respect to time. Here I have showed here dp. Here I have showed this equation. dp by dt is equal to ks, where dp is the rate of formation of the product with respect to the substrate, which is equal to a constant, which is the frequency at which the substrate converts into a product and the substrate concentration. The rate of the reaction involving enzymes also increase as the substrate concentration increases. Initially, what it is said, in the absence of enzyme, the rate of the reaction will keep on going. It will form product. It will when the substrate concentration is present or the substrate concentration is much higher. But it will take longer period of time in the chemical reactions. But if in a biochemical reaction, when the enzyme is present, when the substrate is present in a pretty much concentration, it will easily convert the enzyme. The enzyme will easily convert the substrate into product by following this Michaelis-Menten's kinetics. This, which is the degree of formation of product with respect to time is equal to Vmax, the maximum velocity of enzyme, into the substrate concentration, by Km, the affinity of the enzyme for the substrate and the substrate concentration. So now we can define the enzyme activity as the enzyme unit, or the international unit for enzymes, which is symbolizes as U, or international unit IU, is a unit of enzyme catalytic activity, or 1 unit, which is micromole per minute, is defined as the amount of enzyme that catalyzes the conversion of 1 micromole of substrate per minute under the specified condition of the assay method. So here I would like to show the very interesting thing about the enzyme kinetics. What happened when the enzyme concentration is pretty much low as compared to the substrate concentration, or the substrate concentration is very high as compared to the enzyme concentration. In that case, what happened? The rate of change of the substrate into the product, it will appear like a straight line. It is a constant. It will change. The substrate will change into the product at a constant rate. Why so? Because as in the previous slide I have showed, the substrate fits into a particular position of the enzyme, which is anotherly known as enzyme active site. When the substrate concentration is very high, the active site of the enzyme will be filled, or the occupied from the zero time, and at the end of time t, the preoccupied cavity, or the active site, will keep on converting the substrate already present in the preoccupied space. That means enzyme will not change its velocity with respect to the substrate concentration, as because substrate concentration is very high. This kind of reaction mechanism is known as enzyme reaction. Next is the first order enzyme kinetics. What happened here? When the substrate concentration keep on increasing, the velocity or the speed of the enzyme will keep on increasing up to a certain stage. After that, it will follow a zeroth order reaction, which is the maximum point, you can say, as a Vmax, the attainment of the Vmax. Here you can say the increasing substrate concentration changes the enzymatic rate when the substrate concentration is just higher or equal to the enzyme concentration. That means both the substrate concentration and enzyme concentration are nearly equal. Actually, when this kind of enzymatic mechanism are initially given by Michaelis-Menten, there was a problem with that equation. According to the Michaelis-Menten equation, Michaelis-Menten said that the substrate concentration should be very high to follow the first order rate kinetics. But later, Briggs and Haldane, what they have Briggs and Haldane later they have suggested that no, the enzyme substrate concentration should not be very higher, so that enzyme kinetic should not follow zero order kinetic reaction. It should follow a first order rate of reaction. So here you can see the whatever I said in the last slide, the Vmax, the attainment of the maximum velocity, where the entirely all the active site is occupied by the substrate concentration. Here the substrate concentration is near to zero. From here the substrate concentration keeping on increasing. So this tangential state, you can see it is a hyperbolic curve, and this is a tangential state here. This point is called as first order kinetics, and this half of the Vmax is nothing but the Km. That means Km is where the enzymatic reaction attains half of the maximum velocity, which is directly proportional to the substrate concentration. Now, the important thing is we can see this hyperbolic curve. Now the problem is we cannot directly measure the Vmax and Km from these tangential points on this hyperbolic curve. It is very difficult. So therefore, to calculate the Km Vmax practically from the reactions in the laboratory, we have to follow some other ways. If we get a straight line on behalf of this hyperbolic curve, or if we can convert this hyperbolic curve into a straight line, then it will be more convincing to calculate Km and Vmax. So therefore, Lineweber and Bach, they have there are two this person, Lineweber and Bach, they have invented a equation which is known as linear regression plot here, where linear regression plot where the velocity, the inverse of the velocity is calculated, and the equation of the Michaelis-Menten kinetics is made into a straight line so that we can calculate the Km Vmax easily. Now, if we inverse the Michaelis-Menten's equation, what you can see that the enzyme velocity of the enzyme at different substrate concentration, it appears on the straight line. The intercept of this straight line is 1 by Vmax, and that straight line goes to the negative axis of the x-axis. Where it touches to the negative x-axis, it is minus 1 by Km. Now it is very easy to convert this 1 by Km into Km and 1 by Vmax into Vmax. So it was difficult earlier from this hyperbolic curve. Now it is easier from this straight line. So it's a very important concept I'd like to discuss here, that is the concept of steady state. What does that mean? Usually, in case of chemical reactions, they follow like there are two reactants, it may directly convert it into a product, or the two reactants may go to the formation of a transient phase, which is known as the reactant-reactant transient phase. Okay, then finally a product will form. Now, in case of enzyme, same kind of kinetics follows. Here, what happens that when the enzyme and substrate they go for the chemical reaction, initially they form the enzyme substrate complex, and then after the further modification of the substrate, this enzyme substrate complex, finally it will end up into a product, and the free enzymes will be released. Now, what happened to the substrate in this state? In this state, the enzyme will recruit many ions, water. There will be some rearrangements of the bonds, breaking of the bonds, making of the bonds onto the substrate so that new product forms. So therefore, this enzyme substrate complex should be stable for a certain period of time. So that state is called as steady state. Now, you can see here from this graph that when the substrate concentration is increasing, we can follow this brown line. When the substrate concentration is increasing, sorry. So what happens? The velocity of the enzyme will increase, and finally you can see a steady state arrived. This is a enzyme substrate state. Now you can see from this curve, when the substrate concentration is increasing, so what will happen? The product formation will keep on increasing. But if from the initial substrate concentration, if we can consider the reaction, so what will happen? The substrate will deplete it when the enzyme will convert the substrate into a product. So therefore, we can see this line appears. And here the blue line, you can see that the total enzyme, initially it went down, then again it goes up. Why so? As because when it went down, it forms the enzyme substrate complex. From the enzyme, when it is reacted with the substrate, it forms the enzyme substrate complex, and finally after the formation of the product, the enzymes will be freely released, and therefore the curve again goes up. So therefore, the progress of the curve for the components of a simple Michaelis-Menten equation or the reaction, the except of the transition phase of the reaction before the shaded block, you can see here, the enzyme substrate complex remains constant until the substrate is nearly exhausted. Okay, so from here to here, there is a huge steady state, as because enzyme is formed the complex with the substrate, and hence the synthesis of the enzyme substrate must equal to its consumption over the course of reaction, that is enzyme substrate maintain the steady state. So here we comes to this Michaelis-Menten's kinetics. As we can see here, the enzymes, when it goes for the reaction with the substrate, it forms a bidirectional reaction, as because there may be a probability that enzyme substrate complex forms again, the substrate and enzyme can be released back. Okay, and or the enzyme substrate complex, when it is reacted with the substrate, it forms can goes into a product formation and the enzymes will be released. So here are the rate equations, and the velocity of the enzyme, that means the speed of the enzyme, can be calculated from the Michaelis-Menten equation, that is Bmax S Km plus S. Here the Km is the substrate concentration at which the rate of the reaction is half maximum rate, that is Bmax. Already we have discussed in our previous slide. So now quickly understand what happened to the linear Lineweber plot. As I told you, it was difficult. It is difficult to calculate the Km and Bmax of the hyperbolic curve of the enzyme. So therefore, we can opt for the straight line. This is a regression line, and as I told you earlier, that the initial velocity of the enzyme for each substrate concentration can be reversed, and the entire Michaelis-Menten equation will be reversed back, and it will come to the y is equal to mx plus c, which is a straight line. Here m is the Km by Bmax, s is x, and c, the intercept, is 1 by Bmax. Therefore, this intercept represent 1 by Bmax, and this slope is represented by Km by Bmax. This is m. There are many other plots to solve the enzyme equation for Bmax and Km equation or the Bmax and Km values. Another plot is known as Hensel plot. Here substrate by velocity is presented against the substrate, and Km by Bmax, the slope, and 1 by Bmax can be determined. But the problem of this Hensel plot is that this is a slope, and this slope will represent 1 by Bmax. It is difficult to calculate the Bmax from here. Km is fine. So in that case, we have to initially determine the Km, then we can determine this value. It is difficult. So therefore, Lineweber plot is better than this Hensel plot. Another plot is known as Eadie-Hofstee plot. Here you can see there is a direct conversion. Direct conversion. Here is just the interchange of the equation, and finally y is equal to mx plus c is obtained. And if we can plot this, we can see the Vmax, it comes to the interceptal position of the y-axis, and Km is again the problem. It's the slope. It is difficult to calculate the slope from this for this Km value. So therefore, Lineweber is better in many respects. Now the most interesting thing. So my today's presentation is highlighted on this part, enzyme inhibition. That's why I have given just a preliminary knowledge that about the enzyme, that is classification and its this course of action, and little bit about this enzyme kinetics. So what do you mean by the enzyme inhibition? That means the action of the enzyme will be inhibited by the small molecules inhibitors. Mostly, it will inhibit the substrate binding, or it will inhibit while the substrate already bound to the enzyme in the enzyme substrate complex, or it may indirectly act onto the substrate. It will change the shape of the substrate. It will not allow the substrate to fit into the active site. So the inhibitors play a major role in case of enzymatic reaction, in case of metabolic regulation of the enzymes. So enzyme inhibitor is a compound that decreases or diminishes the rate of the velocity of enzyme catalyzed reaction by influencing the binding of the substrate or its turnover number. Now what is the turnover number? That means what? The unit of it is the unit of product formation per second. Usually what happens to the enzyme activity earlier? The conversion of substrate into product, or conversion of substrate per minute, but the turnover number is production of products per second of time by the enzyme. So it is known as turnover number, which is another, which is called as, in short, called as kcat. The inhibitor may be organic or inorganic in nature. That can be. And inhibitors, usually we are using in everyday life, drugs, antibiotics, toxins, anti-metabolite or natural products of enzyme reactions. Now, types of the enzyme inhibition. So there are several types of enzyme inhibition, and I have depicted here that in three particular feature. First one is reversible. Reversible, the name itself suggests when the inhibitor binds onto the active site or inhibitor, it inhibits the enzyme, it may reverse or it may get back or get out from the enzyme, so that the enzyme's activity can maybe retained back, or the enzymes without hampering the enzyme structure. Second one is irreversible. It is you can say irreversible enzymatic inhibition is very deleterious. Usually it destroys the enzyme's cavity, active site, and the properties of the enzyme's catalytic activity. And another one is another one is allosteric enzyme inhibitor. Usually these kind of inhibitors or the elicitors, they bind onto the enzyme other than the active site. They modulate the structure of the enzyme in such a way that the enzyme active site cannot further process the biochemical reaction. So reversible enzymes, usually the reversible enzyme inhibition usually categorized in three small categories, known as, first one is competitive inhibition, second one is non-competitive inhibition, third one is uncompetitive inhibition. So what are these? Let's have a look.